Let's look at where the Pythagorean trig identities come from. So this is the unit circle, and I'm just going to point to a particular location on the unit circle. And I'm going to say that that has an angle of theta with respect to the positive x-axis. And of course, being the unit circle, the radius is 1. So this goes all the way back to how did we define sine and cosine from the very beginning. So if I tell you that that red point has coordinates x and y, this is the definition of sine and cosine. The x coordinate is the cosine of the angle. The y coordinate is the sine of the angle. And that means that we can connect this to what we know about geometry and say the length of that side right there is the cosine of theta. The length of this side is the sine of theta. And oh, that's a right triangle, so I should be able to apply the Pythagorean theorem, which is why these are called Pythagorean identities. So let's look at the first one, sort of the fundamental Pythagorean theorem. Cosine squared theta plus sine squared theta equals 1. And we use this all the time in calculus and in physics. So that's number 1. And then we can start to manipulate this identity. So my first thought is, what if I divided both sides by sine squared? Then I would get cosine squared theta over sine squared theta plus sine squared theta divided by itself, which is just going to turn out to be 1. And we have other names for these things. That thing on the very left is the cotangent all squared. Sine squared divided by itself is just 1. And then 1 over the sine function is the cosecant function, so I have the square of the cosecant function. Finally, I can just decide to go the other way and take my original Pythagorean identity and divide by the square of the cosine function instead. And we're just kind of doing the same process. We have other names for these things. So cosine squared divided by itself is 1. Another name for sine over cosine is tangent, so I end up with tangent squared. 1 over cosine is the secant, so I have secant squared. So there's our set of 1, 2, 3 Pythagorean identities. I would say out of this list, number 1 is by far the most frequently used. You have to recognize this all the time in physics in particular, and there's no shortage of it in calculus. And then number 3 is quite frequently used. Usually there are workarounds that make it so you don't have to use number 2.